Welcome back. In this video, I will be discussing structure of kidney. So there are a pair of kidneys that are present on either side of the vertebral column in human beings. So they are located exactly at T12, that is the last vertebra, thoracic vertebra. They are extended between the T12 last thoracic vertebra, as they are 12 in number, from T12 to L3 lumbar vertebra. Right, these are the strongest and largest in the body itself, lumbar or. Kidneys are located on either side of the vertebral column. They are extended in between last thoracic to third lumbar vertebra itself. They are retroperitoneal organs. As you know, they are usually covered by peritoneum only one side. Dorsally, they are near the vertebral column. There is no peritoneum itself. Therefore, these are called as retroperitoneal organs. Right, they are grayish red in color. They are reddish in color. Almost in these, right kidney is always somewhat located down to the left kidney. Comparatively speaking, right kidney is somewhat below. This is due to the presence of liver on right side of the abdominal cavity. You would be coming across presence of liver. As a result of this liver, right kidney is present just below. It is accommodated just below when compared to the left kidney itself. On average, some 120 to 170 grams is the weight of kidney itself. So these are right, two in number. There are two kidneys that are present. So this is a kidney, let's suppose. So the extension, cortex region. Cortex is the outermost peripheral region. Middle portion is medullary region when it comes to the histology. So invagination, extension of cortex region deeper into the medullary part of the kidney, divided kidney into many pyramids. Right, this is the cortex region. As a result of this invagination, this has resulted in formation of many pyramids. These are called as renal pyramids, kidney, right? These renal pyramids are almost 8 to 15 in number. That entire a single kidney may contain 8 to 15 such renal pyramids. Renal pyramids are formed as a result of invagination or extension of the cortex into the deeper parts of the medullary region itself. So these renal pyramids, they project into renal pelvis region. They projected into these renal pyramids. Ultimately, they projected into these pelvis region itself. This is called as renal pelvis region. Always, the apex region of these renal pyramids is called as calyx. Right, papilla. The apex region itself is called as papilla. These papilla are having many openings, papillae. Every pyramid itself, these are the pyramidal structures. There are 8 to 15 pyramidal structures. Every pyramid itself is having collecting ducts. So there are many collecting ducts. All these collecting ducts opens into papilla. So these papillae ultimately they open into into these calyx region. The proximal end of these calyx region, remember, calyx means a cup-like structure. There are two types of calyces, plural calyces. So these calyces are major and minor. So the proximal end of these calyces are always right. They are narrow in number. They are narrower in nature. So these narrower calyces usually they contain renal pyramids. I mean, they contain papilla. These are narrower. They are present at the end of the renal pyramids. This is the calyx region. This is in proximity. This is in proximity with the renal pyramid, or simply this portion, apex portion, is called as renal papillae. So they receive urine from Bellini ducts. There are Bellini ducts. These Bellini ducts collects blood from these pyramids, right? These are having numerous nephrons itself. Ultimately, right, they join together, they open together into the calyces region. In between such many minor calyces, right, in between these calyces there are Bertini columns, column of Bertini. Remember, Bellini ducts are different. Bellini ducts are part of renal pyramid. So these renal pyramids are, right, having collecting ducts called as Bellini ducts. These Bellini ducts opens into renal papillae. These renal papillae opens into the renal pelvis region where calyces are present. In between calyces, ducts of Bertini are present. Column of Bertini. This is Bertini. This one is Bellini. That every organ receives blood supply, right, was not shown in this, right. So this also receives from this hilum region. A notch-like structure is there. From this hilum region, renal artery enters. Remember, renal artery is a branch of dorsal aorta. It supplies oxygenated blood. So oxygenated blood is supplied to this kidney via by renal artery. Renal artery enters into the kidney from this hilum region itself. Let's suppose this one is renal artery, right? Again, artery divides into arterioles, arterioles into capillaries. Again, these capillaries again they join together to form venules, venules into veins, right? That vein is again renal vein. So renal vein starts from, right, it exits this hilum region. So this renal vein ultimately joins to inferior vena cava. It becomes the part of inferior vena cava, which is the largest vein in the body itself, or this is called as, right, inferior vena cava or post caval vein, right, which collects blood from lowermost parts of the body itself. Right, there is superior vena cava or precaval vein that collects blood from anterior parts of the body. This is exactly opposite. Now this renal vein, right, this is the part of inferior vena cava. In addition to these, there are lymphatics, nerve endings, etc. They are present at this region. So every organ itself is having this one. So likewise, kidney is also having arteries, veins, lymphatics, nerve endings, etc. So this is a kidney. It opens into, right. These all these pyramids opens into renal pyramids opens into these calyces. These calyces finally open into ureters. Right now, these ureters opens into, they lead into urinary bladder, a temporary storage organ which is lined by transitional epithelium itself. Right, these are ureter, these are transitory organs. They start from this region, hilum region, they start from the kidney, they open into urinary bladder. This urinary bladder temporarily stores excretory material. In case of females, the volume of urinary bladder is always more. Urinary bladder can accommodate more amount of the urine when compared to the males itself. So this urinary bladder ultimately it opens out by means of a urethral sphincter. There is urethra. This urethral sphincter is, right. Right. When it comes to the urinary bladder, this urinary bladder in cross section we come across serosa, muscularis, submucosa. So again, these are the layers: serosa, serosa, muscularis, and submucosa. These are the three anatomical regions present in the urinary bladder itself. There are two sphincters that guards urinary bladder. So these, out of these two sphincters, external sphincter is made of voluntary muscles. This external urethral sphincter is voluntary, made of skeletal muscles, whereas internal sphincter is made of involuntary, smooth muscles itself. This is, right, involuntary. However, the reflex from central nervous system, right, micturition reflex that helps in voiding of the bladder itself. As a result of this reflex, urine will be excreted out. But however, remember, this urethral itself is, this is longer in case of males. It passes through prostate and penis itself, whereas in case of females, it is shorter. Urethral, the passage itself is shorter. That is the reason the incidence of urinary tract infections are more in case of women when compared to the female. Right, urinary tract infections are more. The chance, probability of urinary tract infections are more in women when compared to the men itself. Right, this is lined by transitional epithelia. Already we had a discussion about all these histological aspects in histology of organs. Yeah, in the last video, I have forgotten to mention one thing, that is transamination reaction. Right, when it comes to the urea formation, that I had discussed somewhere in biochemistry itself even. So there is a reaction called as a transamination reaction. So amino acids, right, as you know, let's suppose this is an amino acid. So this amino acid upon transamination get converts into keto acid. This is an oxidative deamination, CH3 NH2H, right. Ammonium will be lost. This is transamination. The enzyme is a transaminase. Remember, there are 14 types of transaminases were reported from human beings. Remember, these transaminase enzymes always requires pyridoxal phosphate, pyridoxine or pyridoxal phosphate. Originally speaking, this is pyridoxal phosphate. This is the coenzyme itself. This is pyridoxine is vitamin B6. Vitamin B6 is a coenzyme. So for the transamination reaction, right, as a result of this transamination, amino group will be transferred. Right, it is transferred onto whom? Right, there is an interconversion. There is another keto acid. Let's suppose this is the keto acid. Now this is something, a keto acid, right. As a result of transamination, amino group will be transferred onto this keto acid. As a result of that, keto acid get converts into amino acid. Amino acid becomes keto acid. When it loses amino group, it becomes keto acid. My intention is, as a result of transamination reaction, transamination always interconverts, right, this is important. It interconverts an amino acid into keto acid, amino acid into keto acid, or vice versa, a keto acid into amino acid. That is the function of transamination reactions. For example, a pyruvate, pyruvic acid is an, right, carbohydrate intermediate, a keto acid, CH3 COCH3. Let's suppose when this pyruvate interacts with some other amino acid, now pyruvic acid becomes amino acid, right. Once it accepts an amino group in place of oxygen, it becomes alanine, right. Second, that is the amino acid. As a result of this transamination, it accepts amino group from some other amino acid. Previously it was a keto acid because it is having CO functional group. Again it is having carboxyl group. Therefore it is called as keto acid or alpha keto acid, because, right, the position is alpha adjacent to this one. Uh, right, carboxyl group COOH. CH3 COCOH is pyruvic acid. As a result of transfer of amino group from that amino acid to keto acid, it becomes amino acid. Now that amino acid becomes a keto acid, like alpha ketoglutarate acid or oxaloacetate, etc. That I am not going into details, but transamination reactions always interconverts an amino acid into keto acid or a keto acid into some amino acid. They connect carbohydrate metabolism with protein metabolism, intermediary metabolism itself. This is in between. Let's suppose pyruvate is a carbohydrate intermediate. Now this carbohydrate is becoming protein, means a carbohydrate can become a protein, means, right, there is an interconversion, they are dynamic, or a protein can become a carbohydrate intermediate, right, like a glutamic acid may become alpha ketoglutarate, a carbohydrate intermediate in Krebs cycle, or oxaloacetate. An aspartate become oxaloacetate, or oxaloacetate can become aspartate, right? Remember. So that these are keto acids are either oxaloacetate or alpha ketoglutarate, etc. These are keto acids. Upon transformation, they become glutamic acid, or they may become aspartic acid, or they may become alanine, etc. This is just interconversion itself. Right? Remember, this deamination is of two types. One is simple transfer of amino group transformation or oxidative deamination. However, ultimately it releases amino group. So this amino group is highly toxic, as I mentioned in the last video. So this ammonium is now it is made to conjugate with some other compound like glutamate. Glutamate becomes glutamine, right? I had to mention in urea cycle itself this one, right? Keep in mind. So this transformation is the reaction that requires vitamin B6 as coenzyme itself, that is pyridoxine. It get converts into even skips base, right? ఆల్డిమైన్ అంటాం జనరల్గా. ఇక్కడ మనకు ట్రాన్స్ఫార్మినేషన్ చర్యలు ఉంటాయి. ట్రాన్స్ఫార్మినేషన్ చర్యలు అంటే ఒక అమైనో ఆమ్లంలో ఉండే అమైనో గ్రూపును అక్కడి నుంచి తీసివేయడం. అంటే ఇది వేరే పదార్థానికి రవాణా చేస్తుంది, సరఫరా చేస్తుంది, వేరే పదార్థానికి మార్చేస్తుంది. దానివల్ల ఏమవుతుంది, అవతల పదార్థం అనేది అమైనో గ్రూప్ని యాక్సెప్ట్ చేసి అది అమైనో ఆమ్లం లాగా మారుతుంది. మొదట అమైనో ఆమ్లం లాగా ఉన్నది అమైనో గ్రూపును పోగొట్టుకోవడం వల్ల కీటో ఆమ్లం లాగా మారుతుంది. అమైనో గ్రూప్ని యాక్సెప్ట్ చేసిన కీటో యాసిడ్ అనేది అమైనో ఆమ్లం లాగా మారుతుంది. ఇక్కడ ఏమవుతుందంటే అమైనో ఆమ్లం అనేది కీటో ఆమ్లం లాగా, కీటో ఆమ్లం అనేది అమైనో ఆమ్లం లాగా మారుతుంది. ఇక్కడ కీటో అంటే ఏం లేదండి, కీటోన్ గ్రూప్. ఎగ్జాంపుల్ CH3COCH3, మనం దీన్ని ఏమంటాం, RCOR కీటోన్ అంటాము. ఇక్కడ కూడా రైట్, నేను ఈ ప్లేస్లో ఏం చేస్తున్నానంటే ఒక యాసిడ్ గ్రూప్ పెడుతున్నాను, COOH. కీటోన్ ఫంక్షనల్ గ్రూప్ని కలిగి ఉండి కార్బాక్సిల్ కలిగి ఉంది కనుక కీటో యాసిడ్ అంటాం. అంటే ఒక అమైనో ఆమ్లం కీటో ఆమ్లం లాగా మారుతుంది, కీటో ఆమ్లం అమైనో ఆమ్లం లాగా మార్చబడుతుంది. ఇది ఎవరంటే రైట్ ట్రాన్స్ఫార్మినేషన్ చర్య వల్ల. ఇది మనం ముందు చెప్పుకున్నాము. కార్బోహైడ్రేట్లు విచ్ఛిన్నమైన కార్బన్ డైఆక్సైడ్ వచ్చింది, లిపిడ్లు విచ్ఛిన్నమైన కార్బన్ డైఆక్సైడ్ వచ్చింది. కానీ ప్రోటీన్లు అమైనో ఆమ్లాలకు వచ్చేటప్పటికి అమ్మోనియం విడుదల చేయబడుతుంది. ఈ అమ్మోనియమే టాక్సిక్ మెటీరియల్. కనుక దీన్ని బయటికి పంపడం కోసమే పరిణామ క్రమం లోపల రైట్ అనేక అవయవాలు ఏర్పడ్డాయి, అనేక నత్రజని సంబంధమైన వ్యర్థ పదార్థాలు కూడా ఏర్పడ్డాయి. రైట్. Right. So when it comes to the microanatomy of kidney, right, these kidney are said to be made of nephrons. So nephrons are structural and functional units of kidney. Right, nephron is the structural and functional unit of kidney. On average 1 million to 1.2 million nephrons are present in a single kidney itself. These nephrons are having renal capsule. Anatomically, it is divided into renal capsule and renal tubule. So this renal capsule is also called as Malpighian. Malpighian capsule. Right, renal capsule or Malpighian capsule, and it also includes a tubular structure. That structure is called as renal tubular structure. Right, renal tubule. Right, now this Malpighian capsule itself is composed of right a glomerulus and Bowman's capsule. Right, renal tubule itself is on the base of right permeability, on the base of structure. Again, this anatomically it is divided into descending loop of Henle's loop, ascending loop. Right, right, this one is Bowman's capsule. right? Glomerulus. This is glomerulus. This funnel, right, cup-shaped structure is called as Bowman's capsule. Right? These two are collectively called as Malpighian capsule or Malpighian corpuscle. This is also called as a renal capsule. Renal capsule or Malpighian capsule. Anatomically, this is made of glomerulus and Bowman's capsule. Yes, this glomerulus is right renal artery. As I mentioned, renal artery supplies blood to kidney. So this renal artery further divides, branches, right, rebranches. So ultimately, it get converted into arterioles. So these arterioles are two in these. This one is afferent arteriole. So this afferent arteriole supplies blood to nephron. This afferent arteriole is having more diameter. When it comes to the diameter, this is having much diameter. It is having more diameter, whereas efferent arteriole is narrower. Diameter is low when compared to the afferent, right? This is the lumen. This is the space available for the blood flow. In this case, this is the only space. So this is efferent arteriole. Efferent arteriole exits, effer exit, that exits from glomerulus, right? That is the exit part of the glomerulus is efferent. That arrives at the nephron is called as afferent. A for arrival, E for exit. There is a difference in the diameter of the afferent and efferent arterioles. Therefore, what happens, right? In between, afferent arteriole again divides, redivides. It is divided into several capillary network, a tuft of capillary network. So there is a tuft of capillary network. As a result of this, as you know, capillaries are always lined by endothelial lining. Within these endothelial lining, right? So these capillaries are lined by endothelium. Within these, there will be space so that they form some fenestrations or openings. So there is an opening in between these capillaries. Now, remember, blood flows at rapid rate in afferent arteriole. Diameter is more. Again, right, it enters into this capillary network. Again, this blood will be collected by these efferent arteriole, but however, due to the difference in diameter, blood flows. Draining is very rapid, right? Blood arrives at a rapid pace, but when it comes to this emptying, it takes much time. It is a gradual process. In between, blood has to, right? Blood has to remain in this capillary network for a while. Within this time, there are certain openings. Again, it experiences some pressure. As a result of this pressure, some of the fluid comes out from these spaces. Now this fluid enters into these Bowman's capsule. So glomerulus is, right, a part of afferent and efferent. It is made of afferent and efferent arterioles. They are differing in their diameter itself. Yes, remember, afferent arteriole, it divides, ultimately enters into efferent. Again, this efferent arteriole further divides. It further divides and redivides. Ultimately, it results in formation of peritubular network around vasa recta. Right, this is the nephron. This nephron further, it is having a highly coiled structure like this. For example, let's suppose this is the nephron. This nephron will be having a highly coiled structure. Let's suppose, all right, this is the highly coiled structure that is closer to this area. Therefore, it is called as proximal convoluted tubule, which is nearer to these renal capsule or Bowman's capsule. This is a distant. Therefore, this is called as DCT, distal convoluted tubule. Right. Again, this efferent arteriole. This efferent arteriole further divides, redivides, so that it divides and redivides, branches and rebranches. It results in formation of, right, a new network, a peritubular network. Peri means which surrounds. It surrounds these tubular structure. This results in formation of highly branched structure. This is called as peritubular network. Efferent arteriole forms peritubular network. So this peritubular network is present around vasa recta. Vasa means blood vessel, recta means which is straight, right? We would be right discuss about these. Again, we will discuss about vasa recta in counter current multiplier mechanism. So this is about glomerulus. Of course, this glomerulus itself is also again having a specialized structure, right? Right. Some of the afferent, right? These endothelial lining of these blood vessels of afferent arteriole, which is in proximity with the distal convoluted tubule, right? For example, right, imagine this is the nephron, Bowman's capsule, right? I will explain about these glomerular apparatus later, just a glomerular apparatus. Now, Bowman's capsule is a funnel-like structure that is lined by squamous epithelium. But remember, the jargon, when it comes to the jargon, the squamous epithelium is called as podocytes. They are called as podocytes. They help in filtration of the blood itself. They are having openings. By means of these openings, this primary filtrate now it opens into, it enters into the lumen or cavity available in the Bowman's capsule itself. This is made of, this is lined by squamous epithelium itself. So the squamous epithelium itself is called as podocytes. So this now opens into renal tubule. This tubular structure is called as renal tubule. Right now, let me go for is a tubular structure. Let's suppose this is the nephron. This is a highly coiled structure, right? Again, this highly coiled structure itself, right? After then, let's suppose this is also another highly coiled structure, right? This is Bowman's capsule. This is renal tubule. Renal tubule has divided into descending loop, loop of Henle, and ascending loop, right? This one is a descending loop. This is loop of Henle, right? Again, ascending loop, descending, right? This is descending, it is ascending. This U-shaped hairpin like structure is Henle's loop. Right now, coming to this one, this highly coiled structure, which is in closer proximity, which is closer to these Bowman's capsule or glomerulus, right? This structure, renal capsule, this is usually referred as proximal, which is closer. Proximal, again, it is a convoluted structure. This is highly coiled structure. Therefore, this is called as proximal convoluted tubule or PCT. Remember, this proximal convoluted tubule is always lined by ciliated cuboidal epithelium. This is ciliated. Again, this is a cuboidal, simple epithelium itself. Remember, most of the reabsorption occurs in PCT region itself. I will discuss later. Due to its proximity to these renal capsule or Malpighian corpuscle, this is said to be proximal convoluted tubule. Similarly, again, right, this continues. Again, there is a highly convoluted tubular structure which is distant from this area. This is called as distal convoluted tubule, DCT. Because of its distant location, DCT stands for distal convoluted, that is away. This is a coiled structure that is away from these area. Therefore, distal convoluted tubule, DCT region. Then this opens into collecting ducts. Several such collecting ducts opens. They open into renal papilla. Renal papilla open into, right, many open into common duct. Then they open into ureter itself. So that in nephron we come across, sorry, a single nephron. That this is the glomerulus. Let's suppose this is a highly coiled structure. Now this is another highly coiled region of this one. Right now this opens into collecting duct. Right. right. This afferent artery, this some of the modified cells of the afferent artery, they are called as, right, juxtaglomerular cells. Juxta means beside, just beside. Glomerulus, that is a part of juxtaglomerulus. Glomerulus is having afferent and efferent arterioles, right? Some of the modified cells of these afferent arteriole, remember, always it is most of the times some of the afferent arteriole. Sometimes it may be efferent also, but most of the times it is afferent. These modified cells of afferent arteriole are called as juxtaglomerulus because these are right just nearer to the, these are present just beside the glomerulus. These are called as juxtaglomerulus cells. They are in proximity, they are in contact with some of the cells of the DCT region. These are called as, these are modified cells called as, right, macula densa. So these macula densa of distal convoluted tubule structure, right? This is a distal convoluted tubule structure. These modified cells are called as macula densa cells, right? These two are collectively called as juxtaglomerular apparatus. JGA. Juxtaglomerular cells are part of the afferent arteriole. Macula densa are modified cells, some of the cells of distal convoluted tubule. So these two are collectively called as juxtaglomerular apparatus. This juxtaglomerular apparatus secretes renin that plays an important role in osmoregulation that will be discussed later. ఇక్కడ మనకి గ్లోమెరులస్ అనేది ఉంది, అఫరెంట్ ఇఫరెంట్ ఆర్టీరియోల్స్ ఉన్నాయి. ఈ అఫరెంట్ ఇఫరెంట్ ఆర్టీరియోల్స్ లోపల అఫరెంట్ ఏ అంటే అరైవల్, ఇఫరెంట్ అంటే ఈ అంటే ఎగ్జిట్ అనుకోండి. ఇది ఎక్కువ వ్యాసార్థాన్ని కలిగి ఉంది, రక్తం వేగంగా ప్రయాణిస్తుంది. ఇది అనేక శాఖోపశాఖలుగా చీలి మరలా అవన్నీ ఐక్యమయ్యి ఇఫరెంట్ ఆర్టీరియోల్ లాగా మారుతుంది. ఇక్కడ తక్కువ వ్యాసార్థాన్ని కలిగి ఉంది కనుక ఇక్కడ రక్తం ఏమవుతుంది, ఎంతో కొంతకాలం ఇక్కడ ఉండాల్సి ఉంటుంది. వచ్చిన రక్తం అంతా కూడా అప్పటికప్పుడు మళ్ళీ డ్రైన్ అవ్వదు. ఈ క్రమం లోపల ఈ రక్తకేశ నాళికలు కనుక వీటి మీద ఎలాగో రైట్ స్పేస్ ఉంటుంది, ఎండోథీరియల్స్ అనేవి సెల్స్ అనేవి దూరం దూరంగా ఉంచబడతాయి. ఈ స్పేస్ ద్వారా ఇక్కడున్న ప్రెషర్ వల్ల ఫ్లూయిడ్ అనేది బయటకు వస్తుంది. ఈ ఫ్లూయిడ్ ఎక్కడికి, బౌమాన్స్ క్యాప్సూల్ లోపలికి వస్తుంది. ఈ బౌమాన్స్ క్యాప్సూల్ లోపల మనకి ఖాళీ ప్రదేశం ఉంది, దీని లోపలికి ఎంటర్ అవుతుంది. రైట్, ఇక్కడ ఈ అఫరెంట్ ఆర్టీరియోల్ వ్యాసార్థాన్ని కలిగి ఉంది ఎక్కువ, ఇఫరెంట్ ఆర్టీరియోల్ తక్కువ వ్యాసార్థాన్ని కలిగి ఉంది. ఈ ఇఫరెంట్ ఆర్టీరియోల్ మరలా అనేక శాఖోపశాఖలుగా చీలి వ్యాసారెక్ట చుట్టూత పరిధీయ నాళాలను ఏర్పరుస్తుంది. మళ్ళీ మనం తర్వాత చదువుతాము కౌంటర్ కరెంట్ మెకానిజంలో దీని గురించి. ఇక్కడ ఈ బౌమాన్స్ క్యాప్సూల్ అనేది ఒక ఫైనల్ యూ షేప్డ్ స్ట్రక్చర్. దీంట్లో స్క్వామస్ ఉపకళా కణాలు ఉంటాయి, వీటిని మనము పొడోసైట్ కణాలు అంటారు. రైట్, ఇది తర్వాత రీనల్ ట్యూబ్యూల్. ఇక్కడ బౌమాన్స్ క్యాప్సూల్ని గ్లోమెరులస్ రెండింటిని కలిపి రీనల్ కార్పజల్ అంటాము. రైట్, లేదా దీన్నే మాల్ఫీజియన్ కార్పజల్ కూడా అంటారు. మాల్ఫీజియన్ ట్యూబ్యూల్స్ పేరు చెప్పిన సైంటిస్ట్ పేరు ఇది. ఈ రీనల్ ట్యూబ్యూల్ అనే తర్వాత రైట్ అనేక కాయిల్స్ మడతలబడిన నిర్మాణాన్ని కలిగి ఉంటుంది. ఇక్కడ ఇమ్మీడియట్గా దీనికి కింది వైపు ఉండేది డిసెండింగ్, అవరోహణ దిగేది. దీన్ని లూప్ ఆఫ్ హెన్లీ యూ షేప్డ్ స్ట్రక్చర్. ఈ పైకి ఉండేదాన్ని ఆరోహణ, పైకి ఎక్కేది అసెండింగ్ లూప్ అంటాము. డిసెండింగ్, అసెండింగ్, లూప్ ఆఫ్ హెన్లీ. అయితే తర్వాత క్రమం లోపల ఈ ట్యూబ్ అనేది అనేక కాయిల్ స్ట్రక్చర్స్, అనేక మడతలు మెలికలు తిరిగిన నిర్మాణం కలిగి ఉంటుంది. ఈ బౌమాన్స్ క్యాప్సూల్కి, రీనల్ క్యాప్సూల్కి సమీపంలో ఇది ఉంది కనుక దీన్ని మనము ప్రాక్సిమల్ కన్వల్యూటెడ్, సమీపస్థ సంవలిత నాళము, దీనికి సమీపంలో ఉంది, అనేక మెలికలు పడి ఉంది కనుక పిసిటి అంటాము. మరలా ఇది రైట్, ఈ బౌమాన్స్ క్యాప్సూల్ గ్లోమెరులస్ దగ్గర ప్రాంతం లోపల మళ్ళీ అనేక కాయిల్ స్ట్రక్చర్స్ ఏర్పడుతుంది. దీన్ని దూరస్థ సంవలిత నాళము, దీనికి దూరంగా ఉంది కనుక అంటాం. ఇక్కడ అఫరెంట్ ఆర్టీరియల్ లోపల కొన్ని కణాలు మాడిఫై చెంది ఉంటాయి, వీటిని మనం జుస్టాగ్లోమెరులార్ కణాలు అంటాము. జుస్టా అంటే బిసైడ్, పక్కన ఉన్నది. గ్లోమెరులస్ యొక్క ప్రాంతం ఇది అఫరెంట్ ఆర్టీరియోల్. అప్పుడప్పుడు ఇది ఇఫరెంట్ ఆర్టీరియోల్లో భాగం కూడా అయి ఉండొచ్చు. ఈ కణాలను జేజీ జుస్టాగ్లోమెరులార్ కణాలు అంటాము. గ్లోమెరులస్ లో పార్ట్ కనుక జుస్టాగ్లోమెరులస్. మ్యాక్యులా డెన్సా, డి ఫర్ డిసిటీ అనుకోండి, డిసిటీలో మాడిఫై చెందిన భాగమే మ్యాక్యులా డెన్సా భాగము. ఈ రెండింటిని కలిపి మనం జుస్టాగ్లోమెరులార్ అపరేటస్ అంటాము. ఈ జుస్టాగ్లోమెరులార్ పరికరం అనేది రెనిన్ని స్రవిస్తుంది. ఇక్కడ రెనిన్ అనేది ఇక్కడ ఒక పదార్థం, రైట్, హార్మోన్. ఇంతకుముందు అయితే మనము RENINN చివరగా 2 ఎన్లు రాసి ఉంటే అది ఎంజైమ్ కింద లెక్క. RENIN అంటాం ఇక్కడ సింపుల్గా, మీకు రిప్రజెంటేషన్లో తేడా ఉంది. NN ఇన్ఫాంట్ అనుకోండి, ఇన్ఫాంట్లో 2 ఎన్లు ఉన్నాయి, ఈ చివరలో 2 ఎన్లు ఉన్నాయి కనుక చిన్నపిల్లల్లో ఉండేది కనుక ఇది ఎంజైమ్ అనుకోండి. RENIN, renin, this is the substance that is released by juxtaglomerular apparatus. It is not an enzyme. Differentiate అటు చేయండి, రెండు వేరు వేరు ఉన్నాయి పదాలు. Right, now this nephron itself is, right, divided into Bowman's capsule, glomerulus, right, this is a highly coiled structure. ఇది డ్రా చేయడం అనేది, రైట్, రైట్, ఇది కాయిల్ స్ట్రక్చర్, ఇది రిప్రజెంట్ చేయడము, ఇది హైలీ కాయిల్డ్ స్ట్రక్చర్, దీని కంటిన్యూషనే, రైట్, ఇది అఫరెంట్, ఇఫరెంట్, రైట్, ఎస్. Now this proximal convoluted tubule is, right, highly coiled structure. This is lined by ciliated and cuboidal epithelium. This is important. CCC, PCT. Distal convoluted tubule is also lined by cuboidal epithelium, but they are not that much ciliated. Of course, they are also having some ciliated cuboidal epithelium, but when it comes to the number, relatively very few ciliated epithelia are present in distal convoluted tubule. Probably this is the reason for reabsorption, right? Most of the reabsorption, right, 60 to 70% of the reabsorption of the primary filtrate occurs in proximal convoluted tubule, right? This is due to ciliated epithelia. In DCT, a few amount of primary filtrate will be reabsorbed. So that is the role of DCT and PCT, and again their composition itself when it comes to the histology, cuboidal epithelium, etc. Right? Remember, in addition to this, DCT is also having principal cells, right, and intercalated cells. Right, these principal cells and intercalated cells are present, they are part of the DCT region. So these principal cells are having receptors for anti-diuretic hormone and aldosterone hormone, means it is involved in facultative reabsorption itself, right? Because of the involvement of hormones, reabsorption occurs in DCT region, whereas in PCT region there is no such requirement, there is no involvement of any external agent like any hormone or any other component itself. This is obligatory, right? Absorption is obligatory in PCT, it is facultative in DCT. So principal cells are having receptors for binding of anti-diuretic hormone and aldosterone hormone. These are having binding sites or receptors itself, whereas intercalated cells are concerned with they are having receptors for, right, blood pH regulation. They are involved in regulation of blood pH itself, so that it is involved in regulation of blood pH and homeostasis itself. Right, when it comes to the nephrons are two types. So on the basis of their localization, nephrons were categorized into two types. In the kidney, let's suppose, right, right, nephrons are of two types. This is cortical nephron, this one is juxtamedullary nephron. Right, cortical means, right, remember when it comes to histology, always the peripheral part is called as cortical region. So these cortical nephrons are usually having a short loop of Henle. Renal duct is very short, therefore remember it is not at all extended deeper into the interstitium or medullary region of the kidney itself. Let's suppose This is the medullary portion, middle portion. This is the cortex portion. Remember, loop of Henle is not that much distributed into the medullary region, so that this is not at all concerned with reabsorption of the primary filtrate, or when cortical nephrons are in action, an individual is bound to lose more amount of water in the form of urine. For example, during rainy season, there is no necessity for a reabsorption of the water, as the water availability is more. Therefore, individuals usually excrete more amount of the urine, means there is no reabsorption at all. Means cortical nephrons are in action during rainy season or when water availability is plenty. The reason is these are having a short renal tubule or loop of Henle, therefore there is no question of reabsorption itself. Or at least you can say PCT and DCT are part of renal tubule, right? More than 90% of reabsorption occurs in this renal tubule. As these are lacking, as these are having very shorter, again it is not at all extended deeper into the medullary region, therefore cortical nephrons are right operative in rainy season or when water is available plenty, or else there are juxta medullary nephrons. Juxta means just at the junction, right, nearer, beside. So this is, these nephrons are having cortical region, right, in cortex region. Glomerulus, Bowman's capsule, etc. are present. Collecting ducts are also present. But when it comes to this medullary region, renal tubule is extended deeper into the medullary part of the kidney. Therefore, this is involved in reabsorption of the water. So that most of the reabsorption, right, this is concerned with reabsorption of the filtrate. Therefore, during on a hot summer day, right, usually you excrete a concentrated urine, or the amount of water that you are going to lose is very low, because water has to be conserved during that season, right? Whenever there is a shortage of water, or depending upon the season, these juxta glomerular nephrons comes into action. When these juxta medullary nephrons are in action, reabsorption, the possibility of reabsorption of the filtrate is always higher proportionately. Then this opens into collecting ducts, సంగ్రహణ నాళాలు, right. Collecting ducts are having papillary ducts. Papillary ducts opens into Bellini. So these papillary ducts are, right, these are part of renal pyramids. The kidney itself is divided into numerous pyramids. So this apex region is having renal papillae. This renal papillae opens into collecting ducts. So these collecting duct is also involved in secretion of some components itself, right. We'll be discussing it in urine formation itself, right, role of collecting duct in concentration of urine itself, right. When it comes to the glomerulus, there is a term which is used in diagnosis also called as glomerular filtration rate, GFR, right. GFR is used as, right, a tool for diagnosis of the kidney functioning itself. This is glomerular filtration, that is the quantity, that is the amount of primary filtrate or urine formed in the glomerulus region. So on average it is 125, at 125 ml, right, on average it is 125 ml per minute itself. This is called as glomerular filtration rate, means on average per day almost this would result in formation of 180 liters of primary urine. But remember, more than 99% itself is again reabsorbed. Therefore, on average 1 to 1.5, 1.8 liters of urine will be formed in individuals itself, because there is a reabsorption itself. There is a reabsorption phenomena. right, right. Remember, as a result of the difference in glomerular afferent and efferent arterioles, blood remains in the tuft of capillary network for a while. As a result of the fenestra or the openings in this network, blood leaks. It opens, it enters into the Bowman's capsule itself. So there exists right glomerular hydrostatic pressure, right? Then there is colloidal osmotic pressure or ancotic pressure, right? Colloidal osmotic pressure, glomerular hydrostatic pressure. In addition to this, right, there is fluid pressure. This is called as fluid pressure or renal fluid pressure. Right. Remember, as a result of the difference in these, so this results in formation of urea itself. Right. The difference between glomerular hydrostatic pressure, colloidal osmotic pressure, or fluid pressure. This is also called as capsular hydrostatic pressure itself, right? Renal fluid, right? This is the renal capsular hydrostatic pressure. This glomerular hydrostatic pressure is always, right? This is almost 60 millimeter mercury pressure. But remember, there are some differences. But however, the net filtration pressure is always 10 millimeter Hg. But when it comes to these, this is different, right? In different textbooks, it was mentioned slightly different. Right? Glomerular hydrostatic pressure, right? GHP minus colloidal osmotic pressure and fluid pressure, right? The resultant is, right? Therefore, this is equal to 60 minus colloidal osmotic pressure. This colloidal osmotic pressure, right? Yeah. First, this is glomerular hydrostatic pressure will be available here because of the glomerulus, right? Difference in the diameter itself. There develops some hydrostatic pressure in this region. So this is a 60 millimeter mercuric pressure. Then there is a colloidal, right? Hydrostatic pressure, or this is also called as fluid pressure. There is then colloidal osmotic pressure. So in these three regions, in the glomerulus region, because of the difference in afferent and efferent, etc., this would result in development of glomerular hydrostatic pressure. It was estimated as 60 millimeter mercury pressure. Then there is a, due to the presence of this fluid in the Bowman's capsule, right? This is the capsular structure. There is an empty void space. Due to the presence of this fluid, it exerts some pressure on these walls. This is called as, right, capsular hydrostatic pressure. This is Bowman's capsule. The fluid present in this is called as fluid pressure, or the pressure exerted by the fluid present in the Bowman's capsule is fluid pressure or capsular hydrostatic pressure. Right. This capsular hydrostatic pressure is, right, 18. Again, colloidal osmotic pressure. So this because of the presence of colloidal particles, there are numerous protein particles, or for example, numerous proteins, right? Or amino acids, vitamins, minerals, electrolytes, etc. In addition to water, numerous solutes are also part of this filtrate. Due to the presence of these all colloidal compounds, it also results in development of some sort of pressure. This is called as colloidal osmotic pressure. This colloidal osmotic pressure is almost, right, 18, right? Yeah, sorry, interchange. This is 18, this is 32, so that 60 minus 50, so this comes around 10. So the net filtration pressure is equal glomerular filtration pressure minus colloidal osmotic pressure and fluid filtration pressure, because, right, they oppose this colloidal osmotic pressure and fluid pressure, they oppose the glomerular hydrostatic pressure. Therefore, we have to add these two things, right? This is due to the pressure that is present in the glomerular region, right? This comes out, whereas capsular hydrostatic pressure and colloidal osmotic pressure, they oppose this glomerular hydrostatic pressure. That is the reason I have subtracted these two. First, I have added these two, colloidal osmotic pressure and capsular hydrostatic pressure. They have to be added, then they must be subtracted from these glomerular hydrostatic pressure because of the opposition in between. So this ultimately results in some final filtration pressure, that is called as net filtration pressure. This net filtration pressure is 10 millimeter mercuric pressure, 10 mmHg itself. Right, remember, the filtration that occurs in the glomerulus is the criteria for functioning of the kidney. In addition to this, creatinine levels are also used when it comes to the kidney functioning itself. Right. This is about glomerular filtration pressure, nephron, PCT, DCT, loop of Henle. Right. When it comes to these collecting duct, right, I think I have discussed already principal cells and intercalated cells. Again, something has to be added again. Right, there are principal cells and intercalated cells. So these principal cells are having receptors, binding receptor cells for mineralocorticosteroid, aldosterone, and antidiuretic hormone or vasopressin hormone. When it comes to these intercalated cells, so these intercalated cells secretes protons, potassium ions, ammonium, and bicarbonate itself. Thereby, they are part of regulation of acid base itself. Right. When it comes to the functions, the kidney itself is involved in many functions. Right. It regulates blood pH by secreting protons or by absorbing protons. It regulates blood pH. It is also involved in reabsorption of bicarbonate, or simply you can say kidney is involved in regulation of acid base balance, not only pH itself. As I mentioned, there is a respiratory acidosis and alkalosis that is always compensated by lungs. There is even metabolic acidosis and metabolic alkalosis. This metabolic acidosis and alkalosis is always regulated by kidney only. Right? Remember, this is important when it comes to the examination. Respiratory acidosis and respiratory alkalosis is there. This respiratory acidosis and alkalosis is always regulated by lungs because it is related to your respiration. Respiratory organ is lung. When it comes to metabolism, ultimately every metabolite, etc., it is filtered in the right nephrons. This kidney is concerned with metabolic acidosis and metabolic alkalosis. Right, this is one of the prime function of the kidney itself. It regulates blood pH or homeostasis itself. It regulates blood volume, right, by absorbing water or by right allowing elimination of water. It changes the blood volume itself, like antidiuretic hormone activity or just atrial natriuretic factors, etc. They are also concerned with regulation of blood volume. They are concerned with regulation of blood pressure. Kidney also plays a role in blood pressure regulation. This regulates osmoregulation, right? It maintains ionic balance, ionic composition. Even finally, kidney is also a part of right hormone synthesis. So it is involved in renin secretion that regulates electrolyte and water balance. It is also part of vitamin D synthesis, calcitriol, vitamin D3, where hydroxylation occurs. Second hydroxylation at 25th carbon atom occurs so that it becomes 1,25 dihydroxycholecalciferol or vitamin D3, functional vitamin. Calcitriol. I have mentioned some people consider vitamin D as hormone also. Right? One is renin, other one is calcitriol, erythropoietin hormone. Whenever there is a stress, especially under stress conditions, erythropoietin hormone is produced by kidney that stimulates hemopoiesis, erythropoiesis especially. This erythropoietin means it stimulates only RBC production itself. Even kidney also secretes prostaglandins. These prostaglandins are derivatives of arachidonic acid. This arachidonic acid generates prostaglandins. These prostaglandins are involved in smooth muscle contraction. For the first time they are reported from prostate gland of the males, therefore they were named as prostaglandins. However, even they are reported from many other cells and tissues itself, so they are involved in gradual contractions. At least, for example, these prostaglandins, they assist in fertilization of the fertilization itself. After fertilization, zygote moves towards uterine region, so that is also assisted by prostaglandins itself. It regulates glucose levels, because these are having some threshold level. Glucose is a high threshold substance, therefore most of the glucose will be reabsorbed. Even it is also involved in regulation of vitamins levels, electrolytes, etc., so that it regulates homeostasis. So these are the functions of kidneys. So kidney itself is concerned with multiple functions in the body.